All right, I'm really grateful to be able to spend the next 15 minutes or so diving a click deeper on what Luma is and what are some of the capabilities that it provides. At its core, as Thomas mentioned, it's an AI native multimodal scientific intelligence platform. It's all about optimizing innovation efficiency in the make, test, decide cycle. Regardless of what scientists are working on, it's all about the process of making something based on a hypothesis, testing that something for key desirable attributes, and deciding what to do next on a repetitive loop. And honestly, it's that loop that is so costly. And it is that loop where we have to drive greater efficiency into the process to really extract the best outcomes. And when we think about the different things, the dimensions you have to bring together in order to make that true, this is really how we and our customers see it. On the top left, it's about bringing different scientific and IT disciplines together, whether it's chemistry, biology, material science, but increasingly data science, computer science, and IT. It's not just about the science. The scientists and the business have to work together within a low-code framework to really drive the agile outcomes that they're looking for. On the bottom left, the scientific techniques are a critical part of the discovery process, and we own some of the best tools that exist in our portfolio that are loved by the customers that use them, whether it's Prism for assay development, Genius and SnapGene for sequence analysis and cloning, which is very important to biologics-based processes, and Protein Metrics for protein characterization, or OMIC and FCS Express for flow cytometry. Moving to the right, we have the modalities, and that word modality means many different things depending on how it's used. In the context of science and R&D, it generally means things in the top right? You're researching small molecules, vaccines, cell and gene therapies, or chemicals and materials. But in the context of AI, in particular, when you think about a lot of the language used around multimodal AI as of late, it's commonly used to refer to text, video, images, and while those are very important data modalities, in science, honestly, the data modalities proliferate well beyond that, whether it's structured and unstructured data, experimental metadata, assay and endpoint data, multi-omics and clinical data, and formats ranging from SMILES, FASTQ, SPML, FCS. So there's a wealth of different information that has to be brought together with and across R&D modalities such that science and IT can collaborate together using these all too important scientific techniques to drive innovation and efficiency into the process. And so what can you do with Luma? At the end of the day, Luma is about Dotmatics, our partners, and our customers building their own low-code scientific applications, each consisting of the following components. At its core, it's low code, as Thomas mentioned, which drives that all too important business agility, making it so it's not just a handover of requirements and then you go off and you figure out it doesn't quite meet the need and then you have to go back to the drawing board. Low code is what enables a much more rapid and agile development process. Scientifically aware storage. We've partnered with Databricks, which has become a fairly ubiquitous leader in the data lakehouse space. For us, that means it can handle unstructured, semi-structured, and fully structured data, as well as the processing of that data in a really, really scalable and efficient way. And that's very important for the types of data volumes we're dealing with. Moving to the outer ring, you have important components such as instrument and data integration, being able to ingest data across files, across databases, across instruments, so that you can get the data into the platform in order to extract value from it. Moving to the next component, you have data management and processing. Really important in these kinds of platforms to move from unstructured and semi-structured to more structured and normalized formats of the data so that you can create relationships between traditionally siloed data sets in order to support higher order processing and insight extraction from that data. The next really important component, and frankly, one that we think about quite differently, is material and ontology management. When you think about material management, whether that's inventory systems or registration systems, one of the very important things we're doing is making the process of registering concepts and ideas through the different phases of its maturity cycle asynchronously and in a way that does not impede a user's natural workflow. And this is very important because these workflows are already pretty complicated, and you don't necessarily know when you're dealing something that's with something that is going to be a promising candidate. And so you need to have the ability to clearly track a lineage of how something evolves over time. From an ontology perspective, we will be shipping a robust schema out of the box to support ontologies, but we will also be allowing our customers to bring their own ontologies into Luma and plug them in a very seamless manner in order to extend the out-of-the-box functionality in a way that suits the specific ontological needs of our customers. Adaptive workflows. Workflows are really important. But in science, workflows cannot be prescriptive, particularly in research, particularly in biologics-based research, where there's a tremendous amount of creativity involved, frankly, sometimes chaos. And in order to wrangle that chaos, the last thing scientists need is to have an overly prescriptive process bolted on top of something that is actually quite variable. And so our workflows seamlessly adapt to the way users work. They do not prescribe linear ordering of steps. They allow freedom of creativity. I will say, however, we're also working on a mode of workflow execution that is more important in the development space that does enforce order, that does enforce that greater rigor. But it's important to have that balance depending on what phase in the R&D process you're really in. Tailored user experiences. To get all of this data into this platform and then get value out of it, we're providing a very beautiful ability to drag and drop charts and dashboards and grids, sequence viewers, chemical structure viewers, all at the tip of your fingertips, such that you can really build very tailored and curated experiences for your users, such that they can accelerate the decision support that they need in order to move to the next step in the therapeutic process. Artificial intelligence. Last but certainly not least, this is at the forefront of how we think about bringing value to our customers, but it is only made possible because of all of these other components, which themselves consume and generate a tremendous amounts of data. That data being well correlated within one platform is what makes the ability to deliver thoughtful and differentiated AI a much greater possibility. Any given application that our customers build with Luma is natively integrated with the world's leading scientific tools and hundreds of instruments. This is all driven by our Luma Lab Connect component, which is a fundamental piece of the Luma ecosystem and has support for hundreds of parsers and growing, and interoperability with all of our scientific tools in our portfolio that support the data exchange between the tools and Luma. And the best part about Luma Lab Connect is that it is live in production with many customers. We're very proud to be working with them, and we're very grateful for the team that has worked so hard to make some of these stats possible. 2,000 connected instruments processing 1.4 terabytes and 260,000 files a day. And this is just the beginning. We are just scratching the surface. Because a lot of this tech is powered by Databricks, the scale that we can expect to achieve here is frankly enormous. And we're very happy to be working hand in hand with our customers to support their largest use cases. And with all of this data flowing into Luma, it's super important that the platform is fair, findable, accessible, interoperable, that word Thomas used, probably the most important of the four, and reusable at its core. Because at the end of the day, these are your files, your instruments, your data, and your work. And it has to be governed, secured, and backed by an open API. From an API perspective, we're supporting REST, GraphQL, and JDBC. And from a governance and security perspective, we're implementing security at the Luma application layer, the data layer, and the infrastructure layer. And what can you get out of all of this technology? What does it really buy you at the end of the day? Well, it's really about accelerated insights, decision-making, and outcomes. And what are some of those outcomes? Well, I'll go through them in brief on the right-hand side here. The first is cross-modality and conjugates R&D. So whether you're trying to identify whether a small molecule or a biologic is best suited to hit a target, or whether you're doing research in a space such as antibody drug conjugates, which combine multiple therapeutic modalities, you need a platform which combines the tools and technologies within the same space in order to make some of those conclusions. Contextualized decision-making at every level. The granularity of the applications you can build with Luma can vary according to your needs, whether it's at the enterprise level, departmental level, or the project level. And those applications can interoperate with each other very seamlessly. The ability to visualize and analyze well-correlated and complex data so that you can quickly identify patterns and insights across data sets is fundamental to what we're bringing to our customers with Luma, because the data isn't just in the same platform, but it's correlated, really importantly, establishing relationships between data sets that are traditionally disparate, but in reality have correlations that should be represented. And the second to last bullet on here actually gets me really excited because the more you use this platform, the more value you get out of it. Digital data capture, at the end of the day, the more data you capture in a structured way, the greater your ability to power adaptive simulation and artificial intelligence. And that's a crucial point because without that, you just have AI. And AI is something that has to be optimized, it has to be trained, it has to improve over time, and you need improvements in the data to power the improvements in AI. And ultimately, enriching existing systems via open APIs is really important because we're under no false impressions that Luma will be the only piece of software deployed at our customers. It's quite the opposite. And so getting data into and out of Luma is super important and something we are building in at the very foundation of what it can do. And so what are some of the types of Luma applications that you can build to drive outcomes? Well, they span the gamut, whether it's in therapeutics, ranging from small molecules to vaccines, to protein therapeutics, or more horizontally focused drug discovery support, such as protein production or assay development or target identification, or chemicals, materials, and agritech, whether you're working on paints and coatings, battery technology, food additives, biopolymers, and biofuels. Luma supports a lot, and there's a very important reason for that. It is not because Luma is hard-coded with specific workflows that address each of these areas. It's quite the contrary. It's because Luma is a composable platform that allows our customers to seamlessly stitch together different workflows, different materials and data structures in order to create the use cases that satisfy these really important areas. One such workflow is the B-cell monoclonal antibody workflow, which will be the focus of today's demo. This workflow is very complex. This is actually a quite simplified version of that workflow, but you can see right off the bat that a lot of our scientific tools are implicated within that workflow, whether it's Omic or Genius Biologics or Prism. Each and every step implicates one of these very specialized and powerful tools. And the screenshot you see here is an example from live product of our adaptive workflows, which in a wet lab is very focused on container operations and being able to deal with materials and fill operations and plan versus actual amounts. And this data serves as a natural extension to the data strategy that gets implemented within this platform. And you'll see that come to life shortly. And ultimately, these workflows both generate and consume tremendous amounts of data. So it really is all about the data. And then I'll put in parentheses, and the people, because people own the data. And if you have data silos, you inevitably have departmental silos. Whether you're talking about raw instrument data, experimental metadata, exploratory characterization, or functional assay data, this data exists everywhere, and it has to be wrangled in order to increase the efficacy of predictive, adaptive, and generative AI. But let's take one example, right? Let's take the example of antibody lead optimization. Let's say you're trying to optimize antibody efficacy and developability via machine learning trained on correlated amino acid sequence properties, homologies, and assay datasets. Some of the items in green here, it's not exhaustive, but it's a representative list of some of the datasets that might be implicated during the process of trying to drive that optimization. So these silos need to be broken down. This data has to not just be aggregated and clean, but correlated such the relationships across them is well understood by the platform. And what does this open up? We get really excited about this. Our customers get excited because once you have this data in the platform in a very well-connected way, you can do really interesting things with AI. And when we think about AI, we think of it in three layers of increasing but complementary differentiation. The first is assistive AI, which provides important differentiation around assisting users with repetitive tasks, such as building queries or doing app configuration. You will also have heard of this type of AI in the case of chatbots and co-pilots, very popular with the advent of generative AI. You see an example here from Luma where a natural language query is typed into the interface. The system automatically generates that query and executes it for you. So very handy, very helpful. But this is really just scratching the surface. Things get more interesting when you move up a rung into the area of domain-focused AI, which for science is all about predicting highly specific scientific outcomes. And you can see our scientific tools in this ring here. And this ties back very, very importantly to something Thomas mentioned. Each of these scientific tools are being heavily invested in, and their R&D cycles run in parallel to each other. So the innovations we make in each one actually compound against each other to deliver greater value to the overall whole within the Luma platform. One such example of this type of AI, you can see it on the right here, is auto gating in omic. So omic is a flow cytometry tool. Flow cytometry basically takes a blood sample from a human or an animal and is able to identify cell populations within that sample. Something that is traditionally manual and sometimes error-prone process. With omics, machine learning is able to happen automatically and saves a tremendous amount of time as a result. At the highest level of differentiation, though, you have what we're referring to as integrated multimodal AI. If you remember back to the very first slide I showed, this is where our customers will be able to natively integrate multimodal data, right? All of those different data modalities in science across all of the different R&D modalities, scientific techniques, and science and IT disciplines to drive simulation and prediction of higher order R&D outcomes. In other words, this is where it all comes together. This is where assistive, domain-focused, and all the different data and scientific modalities are able to be leveraged within a common platform. A great example is the same one that I referred to earlier around lead optimization for antibodies. Another great one is antibody drug conjugates, where you have to be focused on a small molecule and a biologic and optimizing the combined nature of the two in order to attack the target in the most appropriate way. And this I wanted to show, I'm not going to go into it in detail, but I wanted to give you a flavor of how we conceptualize our target data science workflow that we want to provide to our customers. It's all about making sure you can collect and model the data in a well-correlated way, making sure you can pre-process and prepare that data so you can create training sets and then evaluate models that are being trained such that you can publish them. And really importantly, to make this real, to make this embedded within your operational R&D processes, this process has got to be iterative. It's not something that's one and done. It's something that gradually improves as you leverage more and more data and as you get a sense for how things are working and how they're not. And in the spirit of transparency, I wanted to share some of the items we are considering prioritizing now, next, and later across the three dimensions of AI that I discussed. And the important takeaway here is that this is AI for both the scientist, the person doing the specific technique or focused on one step in that workflow, and the enterprise, folks who are more concerned with digital transformation and wrangling data, the vast volumes of data that exist across departments. And we take this very seriously. The team has worked really hard to identify some of these items and are working really hard to identify where we're going to go next and how we're going to bring them to market in the most effective way for our customers. And with that, I want to leave with you with just a few takeaways before I hand it over to Phil for you all to see a really exciting live demo. Luma is the platform that fits the way you do science. It seamlessly adapts to the variability of your workflows and data. It does not require you to conform to it. That's very important. It breaks down data and departmental silos to increase business agility. Ultimately, though, the punchline is about delivering faster time to market, lower costs, and new life-changing discoveries.